Welcome to the solutions video for the Unit 5 makeup exam. Our first two questions. A car and truck are driving along a straight stretch of highway with the car starting 10 kilometers ahead of the truck. The truck is steadily speeding up as its distance traveled is modeled by the equation d equals 1.55 t squared. The car is steadily slowing down and its distance traveled is modeled by the equation d equals 10 minus 0.81 t squared. Okay, pardon the interruption, but we need to figure out when the truck and the car catch. So it's really when these two quadratics intersect. Because we're given permission to go to the nearest hundredth, that means we are given permission to use decimals. That means we can graph it. So this 1.55x squared is our first one, and then the 10 minus 0.81 x squared is the second. Notice that they intersect twice, but they're not going to pass before they leave. We start with time 0. So we can even ignore the negative axes. This is our point of intersection. So to the nearest hundredth, the x coordinate is 2.06, the y coordinate is 6.57. So here the x is our time variable, that's our 2.06, and our y is 6.57. Now here, we've got 4 systems of equations, and we need to figure out the number of solutions for each of the systems above. If it's infinite, we can enter 8. Now again, this is a case where we have the opportunity to use our graphing calculators because we are simply counting intersections. So if we take a look at these, to use our graphing calculators, we have to isolate it. So in our first one, we have x squared plus 5x minus y equals a negative 6. And here x squared minus 5x plus y equals negative 2. I'm going to lean on what we learned in Math 10C about systems of equations and just add the two equations up, noting that we have 2 sign changes. That gives us 2x squared equals negative 8. So this tells us that our x squared is a negative 4. Well, x squared will not be a negative number if x is a real number. So these two equations, which we would have to manipulate to graph on our calculators, but our x squared plus 5x minus y equals a negative 6. And x squared minus 5x plus y equal negative 2. Notice that the second one opens down even though the x coordinate appears positive. That's because when we isolate y, the x squared will be negative. So this has 0 solutions. Now in our next one, we need to find how many solutions we're going to have here. So our first equation, we'll end up dividing it by 2. If we divide this by 2, our 2x squared minus 4x minus 2y becomes x squared minus 2x minus y equals a negative 6. And the reason I did that, we can now isolate y. And our second equation is y equals x minus 1 squared plus 5. So x squared minus 2x plus 6 equals x minus 1 squared plus 5. x squared minus 2x plus 6. The right-hand side is x squared minus 2x plus 1 plus 5. Our x squared and our minus 2x's cancel. So 6 equals 6. These two are two different forms of the same equation. There are infinitely many solutions because they're one on top of each other. So we'll use the number 8 for that as indicated in the question. If the number of solutions is infinite, enter the number 8. Now our second one, both y's are negative, x squareds both have the same coefficient, but our x's don't. So they are guaranteed. When we equate these two, we substitute. We're going to have an equation that's linear. That'll give us one solution for x. Now here, we're going to have a 2x squared in the top one and an x squared over 2 in the bottom. So this is going to become a quadratic. So it will either be 0, 1, or 2 according to the discriminant. Now these will both open up. So they will have two different vertices and two different a values. They will open with two different widths opening up. In order to have one solution, they have to be identical and just be a horizontal shift. So this is going to have two solutions. All right. And for system number 3 above, give one solution as an ordered pair. So when we subtract the second equation from the first, we get a negative 3x equals negative 9, or x equals 3. And then we substitute 3 for x into either one of these. Here we have 9 plus 3, that's 12, minus y equals 2. So y is going to be 10. And notice each of these are for half a mark, so you really get 1 mark for finding that single point of intersection. Now here, the correct graph of the inequality 3x minus 2y plus 10 is less than 0. We start with the test point of the origin. 10 is less than 0 is false. It cannot include the origin, so that makes it either B or D. If we were to treat it as an equality and isolate y, we bring the negative 2y to the right, our x would have a positive coefficient, so we're looking for the one with a positive slope. So multiple choice number 1, the answer is B. Here again, the origin is part of it, and we should have a y-intercept at 3. This is a solid line. So if we let this be 0, 0, we need to have, then when the left-hand side is 0, we have to have 0 greater than a negative number to be true, or 0 less than a positive number. That's true in all cases. When x is 0, we have to have equality when y is 3. That only happens with D. And that's the point on our border. Now, this inequality. Which inequality is the graph above? If we were to isolate y, we'd end up flipping the signs. This is going down, so we need to have a negative 3x squared on the right, which means it's a positive 3x squared on the left. So it's one of these two. And we want y less than our parabola, so it is B. Now, for number 6, we have this linear inequality. Melinda tested multiple points to see which satisfy the inequality. She discovered that the points that satisfy the inequality in numerical order are. So to test, we substitute. We put in 4, negative 2. That makes it 12 plus 4. So our left-hand side is 16. Point 1 does not satisfy the inequality. Number 2 is a negative 30 plus 10. That makes a negative 20. 2 satisfies the inequality. We substitute that negative 4 in, or the negative 4 to negative 6. That gives us a negative 12 plus 12. That's 0. 0 is less than or equal to 12, so 3 works. And lastly, 24 minus 12 is 12. That is exactly equal, so 4 works. Now finally, we have a thingamajig company looking to stay profitable. We need the profits to be revenue minus expenses. Revenue is the number of items sold, and we're multiplying it by the price per item. So our revenue, they currently sell 200 thingamajigs per month at a price of $100. And for each $2 price increase, they lose 10 sales. So revenue is items sold times price per item. The items sold is 200 minus 10x, where x is the number of sales. And, or the number of $2 price increases for x. The whole bracket is the number of sales. Now for the price per item, they're currently $100 plus the $2 increase. So that is our revenue expression. We have to create an expression that represents expenses. That's items produced times the cost of production. So they produce a few extra thingamajigs per month. So that's 105% of the orders. So the expenses, the number of items produced is 1.05 times the 200 they sell less the 10 sales per $2 price increase. And each thingamajig costs $11 to produce. So we're just going to multiply that whole thing by 11. And that is our equation for the expenses. So to create and fully simplify the inequality, which keeps the profits above 0. Okay, so our profit is not equal to 0, it's above 0. So the revenue minus expenses is above 0. So our 200 minus 10x times 100 plus 2x minus our expenses. I'm just going to take our 1.05 and multiply it by 11. So it's 11.55 times our 200 minus 10x. That's greater than 0, but we were asked to fully simplify. So we're going to need our x squared terms. We'll get that by multiplying these two together and only those two. That's a negative 20x squared. Our linear x terms are going to be negative 10 times 100, which is negative 1,000, plus 400, plus 115.5. So that is plus 484.5. Now our linear term, we're going to have 200 times 100 minus 11.55 times 200. We work all that out. And it's 17,690. And this is what has to be greater than 0. So it's a negative 20x squared plus 44.5x plus 117,690 greater than 0. There is our inequality. And the range of prices for which the company is profitable, we could graph it now that we have our equation. So we have a negative 20x squared. Sorry, that was a minus 484.5x. Slipped a sign. 17,690. And that has to be greater than 0. Oh, let me fit greater than y. Now at first it looks like we have a whole lot. But now we see our limits are at 20 and negative 44.225. We have to be careful with this. It is very easy to say that's the price. But no, that is not the price. These are the numbers of $2 price increases. So the upper limit is not $20, it's $140 because that's $22 price increases. Similarly, if we work with these price decreases, then our range is 11.55 to 140. So our X values there are the number of price increases. They are not the actual prices themselves. Okay, so that is an important distinction in this question. We often have to ask ourselves, okay, what was the definition of the variables that we had here? Okay. All right, and with this done, we can submit. And there's that 100% we're looking for.